I guess today we're going to explore something that is kind of a niche topic. It's something that I wanted to explore, and it was brought up by a conversation I was having with some folks around the ability to create basically serverless self-hosted runners for GitHub Actions. And the particular context for this is Azure Kubernetes Services. So the basic premise behind this is a way to create some kind of on-demand compute for self-hosted runners. If you're not familiar with a self-hosted runner, it's basically a runner for GitHub Actions that runs on your compute rather than using the compute provided to you by GitHub. In most cases, if you're running actions, you're going to basically get some kind of compute from GitHub, and your action is going to run on their compute, and you don't have to delegate any of that compute. You don't have to marshal any of that compute. It just runs and it completes. And then that compute is then put back into a pool and then runs somebody else's job. Now, if you need a job to run on-prem, you can do that with a self-hosted runner. And there's a lot of reasons you might want to do this. One of the common reasons is that you need a custom build environment. And that custom build environment has libraries and tools that aren't available on the agents that are coming from GitHub. So you have to build a custom build environment that has all your tools and all your stuff that is something that you would use to build your software, but you still want to host it on GitHub for repos and all the other things there. Another reason is security, and that security might be related to accessing resources that are only available on your network. So maybe your build accesses a file share or a database that isn't a part of something that is available on GitHub. So you have to run it on-prem so that you can reach across your local network, garner those resources and use them as part of your build. Whatever your scenario might be, there is a need for self-hosted runners. So my scenario here was basically how to create self-hosted runners that aren't on 24/7. So in many cases, if you have self-hosted runners, the self-hosted runners basically sit around idle the majority of the time, unless you have a really busy build environment. And they're just simply out there waiting for a job to come up so that they can run. So you have all this idle compute that you may or may not be using. And that idle compute, if you're running that on something like Azure, can cost money. Now, there's probably other ways that you could solve this problem using something like VM scale sets with autoscalers that scale to 0 or whatever. But a common way to build software is to use containers. So you can build containers that have GitHub runners in the container, and you can run those on Kubernetes. If you're running that on Kubernetes, though, you would have to have some kind of 24/7 compute allocated to that runner. And it would basically be running for the duration of whatever it is that you have. And it might not be, the container itself might not be running all the time, but the compute behind it would be, at least most of the time. And you would need the available compute for those jobs to run, unless there is a way to do on-demand compute for Kubernetes, which in the context of Azure Kubernetes Services, there is with virtual nodes. Now, virtual nodes are basically on-demand compute that you can use to run Kubernetes pods and jobs and crons against, and it basically turns on the compute, runs for a specific amount of time, and then once the job is done, the pod exits, and then that compute is deallocated and you're not paying for it anymore. So you basically only pay for the compute on Kubernetes while that job is running. Well, this is possible with a caveat, and I'm going to try to unpack that in a minute. But basically what I did is try to figure out how to use a controller from GitHub that basically allows me to run jobs on a Kubernetes cluster that brings up some kind of pod, runs the job, and then shuts it down once that job is finished. And I basically took that controller, which is a custom controller from GitHub, and wired it up to use Azure Container Instances, or rather virtual nodes, under the hood. And that way the compute itself is also allocated only for the duration of that job as well. So let's walk through this on some slides to kind of get your head around what exactly a Azure Container Instance is and what virtual nodes are. And then I'll show you kind of the idea behind what the build is going to look like. And then I'll show you how I wired it all up using some example code. And just to show you can see how this all kind of fits together. So as a refresher, let's look at Azure Kubernetes Services and how it's set up. So Azure Kubernetes Services starts off with just a basic set of compute, which is a node pool. So every Kubernetes cluster requires that you have at least one node pool. And on a basic cluster, that's usually 3 VMs that are running in a VM scale set on Azure. So a non-prod environment could probably get away with a single node cluster, which is good for like dev and test workloads. But a production workload would typically have at least one node pool with some kind of virtual machines behind it. So that's why I got like 3 boxes here. And that node pool is your primary pool of resources for CPU, storage, compute, and networking and memory that you're going to be using to run your applications and jobs and everything that's going to be in your containers in that particular node pool. Now, what you can do with Azure Kubernetes Services is create a virtual node. Now, a virtual node is basically like it sounds. It's not an actual node. It's a node that gets set up inside of your Kubernetes cluster. It looks like a node and it functions like a node, but underneath that particular virtual node, there is no pre-allocated compute. It's basically virtually available, but it's not actually allocated until you tell it to do something. So behind a virtual node in Kubernetes is ACI, or Azure Container Instances. So this is basically on-demand compute for pods to run or containers to run. So what Kubernetes will do with that virtual node is it will say, I need a new pod that needs 4 CPUs and 8 gigs of RAM. And then Kubernetes will tell that to the virtual node. Then the virtual node behind the scenes will go out and create an instance of Azure Container Instances and deploy your container to Azure Container Instances. And then that container will run for the duration it needs to run, and then it stops running. And then it shuts down, the container exits, and then the CPU resources, the memory resources are deallocated and they're returned back to the pool. And you only pay for the time that actual pod or that particular container was running. So this is a really good scenario for virtual nodes using ACI for jobs that are going to be running on a Kubernetes cluster. So Kubernetes out of the box has the ability to run jobs, which is one of the controller types, and crons, which are another controller type, but basically a scheduled job, if you will. And those will run for duration and then they'll shut off. That's good for things like batch jobs and things of that nature. But it also works for other kinds of jobs like building software, which is the intent behind what we're going to be looking at today. So that's the basic premise of what is available inside of Kubernetes. And the question is, how can we make that work for GitHub Actions and run GitHub Actions jobs? So this is the solution once I had everything working and I got all the kinks worked out. So it basically starts with an action. So an action is just basically a declaration that tells me what I need to do to build software or deploy software. And that's broken down into jobs. And each job has on it a declaration about where you want to run that particular job. And that job can tell it to run on GitHub or it can run on a self-hosted runner, which is what we want to do. So I'm basically telling my actions to run on self-hosted runners. But by design, I don't have self-hosted runners available 24/7. I only want to run those on demand. So I have this runner over here, but it's not allocated. It's not even up and running. So to make that happen, what you need is something on Kubernetes that monitors actions that can create the runners for us. So that's what a controller would do. That's where this guy comes in. This is an action runner controller, and this is available from GitHub. And it's designed to basically scale out runners on a Kubernetes cluster based on whatever scalability criterion that you want to give it. Now, we'll look at that in a moment. But in this case, I want this to allocate a runner on my virtual node. I want to create that on an Azure Container Instance on a virtual node. And so this controller will spin up my runner whenever I queue up a job that is going to be a part of whatever triggered my action. And so that's been queued up. So the action runner gets notification that, hey, there's a job out there. It creates a new runner. And then that runner then will pick up that job and run it on that particular compute. Now, you might be wondering why I have this over here. This Docker on this VM scale set over here. Really, this is my primary set of nodes over here. Now, an Azure Container Instance is basically compute that's available for running containers, but it comes with some caveats. It will run most stuff, but there are some scenarios where it doesn't work. And one of those is running Docker in Docker, which is a way of basically taking the Docker daemon, that's basically the server side of Docker, and running it in a container. To do that, what you have to do is basically run your container in what's called privileged mode, which gives that container a little bit more access to the underlying operating system in the host. So it can actually do things like modify IP tables and marshal things like storage and do things that you wouldn't otherwise want to do with a container. So Docker in Docker basically gives you the Docker daemon exposed in a container, but it kind of has some fingers down into the underlying host. So to make that work on a runner, I needed some way to give the runner access to Docker, because I can't run Docker in Docker on Azure Container Instances on a virtual node in Azure Kubernetes Services. But I can run Docker in Docker on nodes that are your standard affair inside of Azure Container Services. So I basically create an instance of Docker in Docker right here. And what I did with this is I created just a single instance of Docker in Docker on the VM scale set and exposed that using a Kubernetes service. And the Kubernetes service exposes the Docker in Docker endpoint as TCP. And then what I did is I basically configured the runner to do all of its Docker needs over here. Because so much of the builds in Docker, particularly in GitHub Actions, rely on Docker, you need this to be available. Now, it might not be necessary for everything, but it's kind of a foregone conclusion that if you're going to be doing builds with GitHub Actions, you need some kind of Docker context so you can build containers and do things with that. And that's where this comes in. So the runner is actually going to do some of the heavy lifting, but if I need Docker, I can then point the runner to use this Docker in Docker over here. And that is where this will not be a fully, quote, serverless solution. It could, because I have to run this Docker in Docker over here so that the runner will have a Docker context available to it. But everything else outside of that doesn't need Docker will actually run on the virtual node right here, instead of having to shell out everything over to the Docker side of things. So this is a solution that will get it most of the way there, but it's not fully baked yet. So my hope is that at some future date that privileged mode will be enabled on Azure Container Instances. I saw some asks for this in some forums when I was doing some research on about how to do this. But to work around that, I basically said, I'm not going to be able to run Docker and Docker on ACI. I need to get Docker and Docker over on my virtual machine scale sets, run it there, and just expose it to my build agents right here, or my runners, and so that they will have a Docker context that they can use for building and moving and doing different things with containers. So let's go look at the technical implementation of this. This is kind of the conceptual implementation. Let's go look at how I built this. It's really not that complicated once you actually look at the code. Basically 4 Kubernetes resources, but there's some setup that you have to do to get it to run. I'll show you how to do all that, and then I'll show you my code. So I'm here in the Azure portal, and I'm going to create a resource. I'm just going to walk through creating a Kubernetes cluster to show you how to set one of these up using the particular setting that you need. Now, most of the settings are going to be just default settings. So whatever you want to use for the basic stuff, we're going to need to create a resource group. So I'm going to use an existing one here. And I'm going to call it I'm going to call it GitHub runner, and it's going to create a new Kubernetes cluster. I'm just going to use a pretty non-prod instance here, but you could use a more prod-oriented one, and just take most of the defaults here for what I'm going to be doing here. So I could probably just use manual scale here, and we can use 3 VMs. DS2 V2s are fine for this. You could probably get away with a more modest VM. Now on node pools right here, this is where the agent pool is where I need to set up this to run, let's say 3 nodes right here. And let me just type that in. And this is going to be using just a Linux node pool set right here on DS2 V2s, which is going to be great. And then I'm going to click this box here, enable virtual nodes, and that's going to be using Azure Container Instances under the hood for what we're going to be looking at here. So that's where I'm going to be running my GitHub Actions. So I want to enable that, and that's going to get me my cluster configured with 3 nodes plus the virtual node. So I'm going to have 4 nodes on this particular cluster. And the rest of this, I can pretty much just take the defaults on. I don't need a lot of this stuff here. And the validation should pass, and we're going to create this guy. And as soon as this runs, we will create it and come back when it's finished. So while we're waiting that cluster to create, we need to get a personal access token to make this work. So to do that, just come over here to settings, and then you can come down here to developer settings, and then go over here to personal access tokens, and then go to tokens classic here, and then generate a new token. And we can select this one right here and just give it a note or whatever. And an expiration date, you can say never expires. We need just the repo access. That's the only thing we'll need access to. The rest of this stuff we don't need, so just click that. And then once you click create, it will then give you the token that you can copy and paste, and just put that into a text editor. We'll need it in just a moment. Okay, so now that my cluster is created, I'm going to click connect to cluster, and I'm just going to copy this right here. And then I'm going to paste it right into my command prompt to wire up my Azure command line to basically connect to this particular cluster. Now, if you don't have kubectl installed or Helm installed, you'll need to install this. I'm not going to go through how to install those. You can just Google install Helm on Windows or Linux or Mac, whatever you're using. Install kubectl. It's pretty straightforward depending on whatever platform you're using. And once you have that, now everything should be wired up and ready to go. So I should be able to do kubectl get pods and do -a, and that'll give me all the pods that are currently running, which is basically just all the system pods that are available. And these are just all the baseline pods that come with a blank Azure Kubernetes service. There's nothing running on this right now other than just the core stuff. So let's go ahead and get this ready to run the GitHub runners. So there's a couple of commands that we need to run against this so that it will be able to run those actions. So there's a handful of commands. They're not that hard to run, but the commands themselves can take a while depending on the size of your cluster, the state of the internet, the state of Azure, and a lot of other factors. But I'm going to basically show you those commands, and then you run those commands, and then everything will be up and ready to go. So the first command that we need to run is basically to get a repo, and this is installed on Helm, and this is a repo for what's called Cert Manager, which is basically a certificate manager for things running on Kubernetes. It's used for things like webhooks and other similar resources. And you can add this to your local Helm. I've already done it, but once you've done it, it'll be available there for whatever cluster you want to use, and you run helm.update, and then it will update that particular repository, and then you install Cert Manager on your cluster running this command. And I'll link all these in the video description below, but basically this one is saying helm install Cert Manager, and this is telling it where the repo is, and this is the namespace Cert Manager. It's going to create the namespace, what version you want to use. The version number will probably change depending on whatever you're using and whenever you install this. Currently, as of recording, this is version 1.10.1. And then you want to set install CRDs, and this basically installs some basic certificates on this. You can do this with Helm, but you can also do it with kubectl as well. But if you just say install CRDs, equals true, it will have one step rather than 2 steps, and it just makes the whole process run a lot smoother. And you can run this. This can take a while to run, so just sit back, go get a cup of coffee, and let it finish. Now we're ready to install the actions themselves. Now to do this, we just need to add another Helm repo, and this command is what you would do for that. It's just another repo, and again, in the video description below, we'll have a link to these commands so you can use them. And then update the repo. I've already done this, so it's just going to tell me that everything's there. And then once you run this, you need that GitHub access token that we just created. So I'm going to show you the command and where you're going to put this. It's going to look like this. Whenever you run the command, it's going to have a place for your token that you need to put in, and right here. And that's what it looks like. It's where you have this auth secret right here. And this is where you would put in your GitHub access token, your personal access token. And this will install the action runners and connect it to your particular GitHub account. Now, we haven't got down to the repository level yet. We'll do that in a minute, but this gets the controllers on your Kubernetes cluster connected to your GitHub account so that it can read things like jobs and so on that it needs to use for creating that virtual node, and then creating the runtimes in those virtual nodes so that you can then run your jobs. So I'm going to run this off camera, and then we'll come back when it's finished. So it looks like everything finished. I can basically validate that by looking at kubectl get pods and doing a -a. I'm basically looking for cert manager to be up and running right here, which it is. This is where we see the cert manager running, and then this is the action runner pod for that. So this tells me that I have my cert manager running, and I also have my pods for the controllers that control the runners. And there's a few custom commands that we can use for runners. So I can do kubectl get runners, and this will show me the runners that I currently have deployed. And currently there aren't any. So I'm going to deploy a runner in a moment. But this will tell me the current running runners that are available for running my GitHub Actions. So everything is installed, my cluster is provisioned. All I need to do now is allocate the resources to run a job. So to do this, we're going to just use some good old-fashioned Kubernetes manifest to do this stuff. So let me show you what that looks like. It's just basically a bunch of code, but I'm going to walk you through the components to show you how that maps onto what the architecture that we looked at the beginning of this video. Once we have everything set up, running this part is actually pretty easy to do, but there's a few things that you'll need to customize in the code, which again is going to be linked down below, that you will be able to use to run your workloads on a Kubernetes cluster using virtual nodes. So here's my manifest file. It's got 4 parts to it. The first part is pretty much a standard service on my Kubernetes cluster. It's just exposing a port to a cluster IP, in this case 2375, which is the port for Docker. Now this deployment is where I'm creating that Docker and Docker port part that will run on the virtual machine scale set. Because like I said, whatever's inside of the container instance won't be able to run anything that's Docker related unless it has a Docker context that it can reach, which in this case is something external. And so this one is basically using an image maintained by Docker called Docker and Docker. And this one right here uses a command to start this. And so this command right here starts it on 2375 on every available IP address. And then of course, this is what the service picks up here and exposes it to the cluster. And this is now reachable as a Kubernetes service on my Kubernetes cluster by other pods and other things running on my cluster. Now you could lock it down using network policies and other things, but for our purposes here, this will work just fine. Now these next 2 parts are the parts that get into the particulars around the action runners. This one right here is a runner deployment. So this basically tells the runner what to use. So you can use custom images on this if you so choose. You could build a custom image that has the agent for the GitHub runner installed in it, and you can expose that using a custom image. I'm using one of the standard images right here. It's just this one's SummerWinds, Actions, Runner, Docker, and Docker. The only thing I'm doing to this image is I'm basically changing the Docker context by changing the Docker host right here. to point to my service that I exposed up above this. And that way this gets a Docker context. Everything that will build in the container on my Azure Container Instance will run on the actual runner itself. If the runner itself needs something outside of itself to run some kind of Docker command, then it will run that on my Docker and Docker instance right here. So that's kind of two parts to it. So if your build will build everything inside of the agent that is going to be running on Azure Container Instances, then that will not even go to Docker. So everything would run basically on this image right here once it is up and running. If it needs something for Docker, it will then shell that out. So it's kind of a two-part solution, not truly serverless, but it's getting there. But all that is to say that this does work for most everything that you'd be doing. So if, say, maybe a Node.js deployment, everything that you need to build a Node.js app is already in this particular image. So it wouldn't use a Docker portion to do that. You could just build the image and then everything's good to go there. Now, this one does do something to get it onto the particular nodes that we want, the virtual nodes, and that's this tolerations piece right here. So with a toleration, that basically tells Kubernetes where it wants to run these kinds of workloads. And this toleration basically says that it wants to run on the virtual node, so that every virtual node on Kubernetes that is running on my Kubernetes cluster on Azure gets a taint. Basically, that is a basically metadata that tells me something about that particular node set, whatever that might be. And a virtual node basically has a taint that looks identical to this. It's got a key called virtualkubelet.io/provider. And basically what this is looking for is, does this exist? And if so, then it will allow this particular workload to run on that particular node. And this is how you can set up different kinds of compute. So if you have ARM nodes, you have x86 nodes, Windows nodes, Linux nodes, whatever they may be, you can use taints and tolerations to tell the containers where they need to run. And this one, I'm just basically saying use the virtual nodes instead. And this line right here tells me what repository to run this against. In this case, I'm using this repository right here. And I'll show you that repository and the associated action in just a moment when we go over to GitHub. Now, this down here is the actual scheduler for this auto scaling on this guy. So this is the part that's going to be able to scale up and scale down whenever demand becomes available. So I don't have to run this 24/7. So to make this work, I'm basically saying I want min replica 0, max replicas 5. So I can have up to 5 runners running, but I want to scale to 0 if possible. So that means basically if it's idle, 0. And these rules right here will allow me to scale up and scale down. So scale up threshold, if there's jobs available on this, it's going to keep incrementing until it either hits the max replicas or the job's complete. And then it's going to start scaling down once it hits 0. So it's going to scale up by a factor of 2, and scale down by a factor of 0.5. So it'll add 2, then 4, then 5, 2, then 5 rather. And then the scale down basically halves it. So it basically go from 5 to 2 to 0 for the number of runners right here based on these rules. So that's the auto scale. So that scales up and scales down. It'll go to 0. And then because I'm using the virtual nodes, I won't incur costs because of that. So that is the manifest. Let's go deploy this and see how it runs on Azure. So to run this, all I need to do is run a kubectl command, kubectl apply-f action.yaml, and that's going to deploy all those resources to my Kubernetes cluster, and I can come back when that's finished. So we can poke around on the cluster to see the status of it by just running some kubectl commands. So if I do kubectl get runners, we'll see that there are currently no runners. And if I do get pods -a, we'll see that the pods that I expect to be there are the ones that are running. So I just have the action runner controllers, the cert manager defaults, and of course all the kube system pods. So everything looks like it's installed and running. Everything is ready to go. So to trigger this, I need to make a change in my repository. So let's go over to my repository that I'm using called DOS Games. And this is basically just a little repository I use for playing with things in Kubernetes for demo purposes. And I've created a workflow on this one. That basically just builds a container image. And this one runs a basic Docker command, Docker build. And there's my Docker file, and there's the tag. And this is the part that tells it to run on a self-hosted runner, which is right here. So that points to self-hosted runners. If you want to see the self-hosted runners for your repository, if you come over here to settings and click on action, then click on runners, you should see no runners right now. I don't have any on here since I've removed them all for this particular one. I haven't created any yet because I haven't changed anything yet. So to create a runner, I'm gonna have to trigger something that will create a runner and then build whatever it is I'm trying to build here. So to do that, I'm just basically going to update my something in my repository here. I can make a trivial change. So I could just remove a few lines from the README right here and commit that change. So I was going to commit and push that change. And that's also going to kick off a build. So I can see that it's now kicked off, and I drill down to this build right here. As soon as it gets queued up, we should see that it's waiting for somewhere to run this job because the runner has to be available. So now behind the scenes, Kubernetes is getting informed that, hey, there's a new build out there. There's a new workflow running, and there needs to be a runner available. So I need a job. So back over here, I should be able to start to see some of these runners being deployed. So this is now running. This spun up the new runner for the repository DOS game because I created a job in the background. And so I'm gonna look at the pods. And let's do -O wide here so that we can see the actual compute that's all running on. We should be able to see our runner on this right here. I moved the -A tag so we can just see the ones in here. We can see that's running on the virtual node. And that is now creating that behind the scenes. So let's let that run, and we'll kind of keep this open while this is provisioning, and then we should be able to see the execution of that job right here once it starts. So this is the container build that's happening on the actual node. You can see the output here being streamed back to the browser, but that is actually running on the Kubernetes cluster. So let's let this run. I just basically compressed the time so it wouldn't take a long time to build. But now once that finishes, we can go back over to our cluster and see how it scales things back down once a job finishes. So I just ran the command to get a list of pods. So this is where it added the runner and then removed the runner. We can see it where this is where it was running right here. And then I ran this a few minutes later, and then it's been removed. While that Docker and Docker image is still running, this one added it and then removed it after it ran for a while. And now it's done running. So it scaled it back down to 0. So that container instance is no longer needed. So I'm not paying for any kind of compute underneath this while it ran. So this solution, you can see, does work. It's not a foolproof. There's certainly some things that could probably be improved on it, but you can use the virtual nodes for running GitHub Actions and other similar tasks that are more job-oriented, especially for CI/CD work like this, and it's pretty easy to wire up. So all the commands are in the video description below, as well as a link to any of the source code files as well. Basically, that Kubernetes manifest file, if you want to check that out for your purposes. But all in all, this does work, and maybe you can use it in your CI/CD pipelines.